still in 1.4.3 area of a region. So now we're going to focus on area between two curves. So if f and g are continuous throughout with fx is greater than gx, then the area of the region between the curves y equals fx and y equals gx from x equals a to x equals b is the integral of f minus g from a to b. So as you can see from the diagram here, okay, we can see that fx is above gx. So in order to find the area enclosed between fx and gx, we need to integrate both. But first, if we integrate fx fully, okay, we get the green area here, right? And but we don't want the pink area, okay? So the pink area is actually represented by the integration of gx. So if we integrate fx and then take away the integration of gx from that, we're going to get the area enclosed by the two curves. Now let's try example 11, question 1. The two curves y equals 12x minus x squared and y equals x squared plus 16 intersect at points A and B. So first we're going to find the coordinates of A and B. Alright, so here is the diagram. Okay, so this is the graph for y equals 12x minus x squared, and the other one is for y equals x squared plus 16. So the pink color here, the pink region here is the area of intersection between the two graphs, and A and B here represent the x coordinates of the intersection points. Okay, so in order to find the coordinates of A and B, we need to solve the equation simultaneously. So let's take equation y equals 12x minus x squared as equation 1, and then y equals x squared plus 16 as equation 2, and then substitute equation 1 into equation 2. We get 12x minus x squared equals x squared plus 16, and then rearrange that. We get 2x squared minus 12x plus 16, and then simplify. We get x squared minus 6x plus 8, and factorize that. We get x, so 4 to negative, therefore x is equal to 2, x is equal to 4. So in order to find a y coordinate, we need to substitute x into any of the equations. So when x is equal to 2, y is equal to 12 times 2 minus 2 squared, which is 24 minus 4, which is equal to 20. So A is 220, and then when x is equal to 4, y is equal to 12 times 4 minus 4 squared, so 48 minus 16, which is 32. So B is 432. So question B requires us to sketch the two curves on the same axis, which has already been solved. And now in order to find the area enclosed by the two curves, we're going to integrate. So from 2 to 4, first the graph that sits above the other graph is 12x minus x squared minus x squared plus 16 dx, right? And then open the bracket and rearrange. So we get negative 2x squared plus 12x plus 16. Okay, and then integrate that with respect to x. We get negative 2x cubed over 3 plus 6x squared plus 16x, and then the boundaries are to 4, and then substitute 4 into the boundaries, so we get negative 32 over 3 minus 40 over 3, and finally the answer is 8 over 3 unit squared. And now for question 2, there is a correction from what you have in the lecture notes, and in here it's written in bold. So for question 2, find the area bounded by the curves y equals sine 2x, whereas in the lecture notes it says y equals 2 sine 2x. So the correct one is y equals sine 2x, which is this one, and the answer is the square root of 2 minus 1 unit squared. And for question 3, the answer is 10 over 3 unit squared.